Okay, so welcome to video 2, where we're going to go over cranial dental anatomy, basically what the skull looks like, and postcranial anatomy, what the skeleton looks like from the neck down. Okay, so first, cranial dental anatomy. Okay, so this is where I would ask you in class, what differences do you see? So we have Neanderthals on the left, Homo sapiens on the right, that is humans. And perhaps the best way to illustrate differences is to overlay them on top of each other. And since you have no say in this, I will just tell you what the differences are. So you can see here that the middle of the face juts out. We call that midfacial prognathism. And the skull is quite long, right, such that it protrudes past the back of the human skull. And you have this bun of bone here on the occipital, which you might call an occipital bun. Okay, so human on the left, Neanderthal on the right. So this is the range of brain sizes in humans, and this is it in Neanderthals. So you can actually see that Neanderthals have larger brains than humans. Not by much, but it's there. And in fact, the 1750 figure belongs to this cranium from the site called Amud, which I don't believe I talk about. But yes, that is the specimen in the hominin fossil record with the largest brain. So congratulations to Amud. Okay, Neanderthals have a long, low brain case, so very similar to the earlier hominins. They have a low receding forehead, which is part of that long, low brain case. And again, so the low receding forehead, similar to earlier hominins, they don't have the nice vertical forehead that humans have, which is associated with a more developed frontal lobe, which controls kind of higher executive cognitive functions. And yes, Neanderthals have an occipital bun, so they just have this bun of bone on the back of the cranium. And as I mentioned, when I overlaid the human on top of Neanderthal, the mid-face of Neanderthals stick out, and that's known as midfacial prognathism. And Neanderthals do not have a chin. So no hominin species has a chin except for us. And I'll go over that more next lecture. Okay, here's another view. Neanderthals have strong double-arched brow ridges, so similar to archaic Homo, though not nearly as robust as an archaic Homo. And I mentioned this in the previous lecture, Neanderthals have these inflated cheeks. So I like to think of them as bee stung, whereas modern humans, they have a depression here, which again, you can feel on your own face. And Neanderthals, as I mentioned in the last lecture, have a retromolar gap. So you have a gap between the last third molar and the rising part of the mandible. And Neanderthals have a massive nasal aperture, which means they had a massive nose. Why do they have such a large nose? Well, if we zoom in, so this is the Gibraltar specimen, again, that's second Neanderthal specimen discovered ever. There's this large projection here, right? These are known as turbinates. So these are quite large in Neanderthals. What is the function of a turbinate? Well, a big nose and turbinates warm and humidify the air. So the turbinates help increase the surface area that incoming air is exposed to. And what that does is it warms and it humidifies the air, which is super important when you're living in cold weather where the air is cold and dry. So the big nose of Neanderthals is an adaptation for them living in Ice Age Eurasia. Here is an image that shows you and emphasizes Neanderthals and how they look different than us. So what you do is you can take a modern human and then you can warp it so it has Neanderthal features. So you can see here, right, the low receding forehead and the brain case is long and low, the brow ridges, the projecting mid-face, huge nose, and no chin, whereas this one has a chin. Okay, so Neanderthal cranial dental anatomy in a nutshell. Neanderthals, very interestingly, also have anterior wear on the incisors. So if you look at the incisors, the front side is completely worn down. You do see this on some archaic Homo specimens, but this feature is quite prevalent and is associated with Neanderthals. So why do Neanderthals have such drastic wear on the front of their incisors? Well, it was thought that Neanderthals used their teeth as a third hand, so to speak. And so here is a Neanderthal gripping a skin with its teeth, stretching out with the left hand, and using a stone tool to scrape off fat and other disgusting things so they can make clothing or shelter from the skins of animals. And it was also thought Neanderthals could have also butchered this way, where they gripped meat in their mouth, held it with the other hand, and was just cutting it up. So all this induces a lot of stress on the teeth and causes that wear on the front. Okay, so let's look at the postcranial, everything from the neck down. So we know a lot about Neanderthal postcrania, and here, right, we also have pretty much skeletons. And the reason for this is because for one reason or another, Neanderthals started burying their dead. So I will go over this more in the behavior videos, but remember from the taphonomy lecture, burial is the first key step to becoming a fossil, right? So when you're buried, you're not exposed to predators, to animals running around and trampling bones. You're not exposed to UV rays, which break down bones. And that's why we get such remarkable skeletons, which we never see in earlier hominins. It's all because they were burying their dead. Neanderthals were short, stocky, and robust. So here's a reconstruction of a Neanderthal. Here's an artist's depiction of a Neanderthal compared to a human. And Neanderthals have often been described as Olympic weightlifters. So short, stocky, and just super, super muscular, which we can see on the bones. The muscle attachments are much more pronounced. You see much more distinct bony ridges for muscles to attach onto. So this body type is actually informed by the bone morphology. So why are hominins so short and stocky? So there's this thing in biology called Bergmann's rule, where you see larger body sizes in cold climates. And there's Allen's rule, where you see shorter extremities in cold climates. So let's see that in a picture. So here we have an Inuit, cold climate, and here we have a Sudanese individual who lives in a hot climate. So you can see here the Inuit is shorter, the torso is wider compared to the Sudanese individual, right? And the limbs are shorter than the Sudanese individual. And you don't only see this in humans, you see it in other things like rabbits, or in the Arctic, right? This rabbit has short ears, short limbs, kind of a fat, round body. Whereas a rabbit in a hot climate will have long ears, long limbs, and kind of a more cylindrical, less spherical body. So less exposed surface area lowers heat loss, right? And this is because if you have shorter limbs and a more spherical body, the ratio of surface area to volume is low. So again, you'll have less exposed surface area, less of your body is exposed to the air, so that means you retain more heat. So to illustrate this, let's do a thought experiment. So which will cool more quickly? This cup of hot coffee, right? And because it's in the mug, it does have this more spherical shape. Or coffee that's spilled over and has spread out and is flat and has very high surface area, especially relative to its volume. I'm sure you will agree with me and say that this is what will cool more quickly. Again, because has more surface area exposed to the air relative to coffee in the cup. Okay, so to really drive this point home, right, in a hot climate, you're going to have something that at its most extreme will look like a stick figure. So super skinny and super long limbs, and a super long and a super skinny torso. Whereas in a cold climate, right, maybe you could predict the limbs will get shorter and stubbier, as will the torso. It will get shorter and stouter. So it pretty much looks like a sphere. And at its most extreme, it will look like Kirby, right? You're going to have a torso that's perfectly spherical with these really short, fat limbs. So Kirby, according to Bergman's rule and Allen's rule, is made for the cold weather. Okay, and here's a reconstruction of what a Neanderthal looks like. So in summary, right, very muscular, robust, stocky, whereas a human, on the other hand, less muscular, gracile, and I couldn't think of another good adjective, so I just went with svelte. So there you go. And so if you remember, this is a historical reconstruction of Neanderthals, right? Very hairy, brutish, ape-like, stooped over, very much in contrast to the previous slide, where that reconstruction of a Neanderthal looked very human-like. It was just shorter and stockier. So the question is, would you actually notice Neanderthals walking around today? So according to more recent reconstructions, they actually do look very human-like, unlike the more historical reconstructions, right? So for example, see here, here, and here, right? So, up to you. If you saw this individual on a subway, or a bus properly clothed, would you even look twice? Same with this individual or this individual, right? And to really drive the point home, I actually kind of faked you out because this isn't a Neanderthal at all. This is actually a human. Specifically, he is a player on a rugby team. So this just illustrates how much overlap there is in the anatomy between Neanderthals and humans and how that manifests itself in the physical appearance, right? So very much in contrast to these older reconstructions of Neanderthals, which are ultimately based on Boole's faulty reconstruction and interpretation of that La Chapelle-Austin skeleton. And in fact, it's often said that Neanderthals, if they just put on a hat to kind of hide that low receding forehead, you wouldn't even think twice if you encounter this individual on the streets, right? So here's the Neanderthal reconstruction with a hat, and here's human reconstruction with a hat. And this one's actually, he's actually a very famous paleoanthropologist. This is Milford Wolpoff, and he often sympathizes with Neanderthals and is against all the kind of negative stereotypes surrounding them. And he often illustrates this by saying that he looks like a Neanderthal. So, he admits it. Okay, so that concludes the second video. Third video, we're going to move away from anatomy and start looking at behavior as it's manifested in the archaeological record. We'll start with stone tool manufacture and use and look at the diet of Neanderthals.